maybe could we take a moment and draw a little bit of a class diagram? Or on the whiteboard, maybe show mass and then
Okay.
the things it brings in,
Okay. All right.
just so we get the big picture again.
Okay.
In the C++
So
world.
for this purpose, let me just open.
Okay, sorry.
Otherwise, I cannot recall what I did.
Oh, files, come on.
See, sometimes this happens when I actually talk to Mike Stark. Some of them, the Mike Stark. Actually, Mike Stark and I actually had the meeting, and when he and I had a meeting, he said, "Oh, I'm aging. I sometimes experience a senior moment. I'm 45 years old."
Oh.
He said, "I'm 45 years old, and you look so young." Actually, he is mentioning to me, "You look so young. You must be maybe 40 years old. 5 years later, you will understand how I am doing." And I said, "I'm 50 years old."
I got a decade on that.
I'm 50 years old. And he became quiet.
My birthday is on Friday, and I will be 55. Double nickels. So you can start a new career at 55. Yeah.
Alright, so so we have how many? 19 separate files. So 19. So again, let me just draw the master and slave. So master. The master actually used the mass.cpp. And this inherits the on the other hand, the slave actually use master.cpp and have the slave actually as an independent program, which is mprocess. .cpp. That actually includes the main program, main function, and then generally, after establishing the connection, just read a message, do a cap on the read, and do you find out the corresponding commands, and do some action. So the master, the actual program is the user application. So user application, in this example, I wrote this user application in main.cpp. in process, the how can I do it? This is not inherited, just used here instantially. Okay, so this is the basic structure. Then thereafter, SSH2 connection. I think SSH2. And from the master CPP, this actually use SSH2 connection. SSH2 connection. That's CPP. This really.
It's a capital S. It's kind of weird.
SSH2's connection is real. Let me check class. That's YouTube, I'm sorry, YouTube. So utility.cpp actually use the, I'm sorry, SSH2 connection.cpp is the quite simple program, and that just simplifies SSH2 unique socket read and write function. This has been just modified into read and write, so that I don't have to worry about the SSH2 unique read and write. So utility. So utility.cpp established the connection. And then even launch and process. And then SSH2 connection.cpp. It's just good for writing, reading data through the SSH2 connection. So then how about socket.cpp? So let me check the contents of the socket. So we have multiple slaves. As I mentioned previously, each slave actually has inter-slave connection. These sockets inter-slave sockets are maintained through sockets.cpp. So the utility is also used within the process. Exchange helper, right? We need to send message, receive message. I'm sorry. So utility.cpp is working share with SSH2 connection and just only focusing on SSH2 connection. So this is what utility.cpp is not used for inter-slave socket communication. Exchange helper, instead exchange helper .cpp actually use the socket.cpp and exchange message.
And it also includes a connection back to the master, right? Because
Yes, there is also connection to the master.
so the SSH2 connection is only for
Sending the commands.
sending the commands, action. Okay. So it could be called the internode sockets instead of just the slave.
Internode.
Yeah.
So I think the rest of it is actually quite easy. Now, there is mnode. I think I mentioned about it, mnode. Once the connection is established, and then mnode mnode include this connection. So these are used for establishing the SSH connection, and once the connection is established, then mnode actually maintain this connection. So then, rest of it is places and agents. Main program will create places. That includes call, Exino, and this is actually inherited from place, C-space. Place space is instantiated in the slave process. So the same thing that is said for agents. So we are done the agent space. What else do we have? Base class and the DLL.
Live class, Miller class. Base class.
So let's check the base class. Oh, yes. So the base class. So in addition to places and agents, we also need to provide agent.cpp, place.cpp. Right? Should I use? Maybe. Which color should I use?
Red, because it's going to be written.
So, I should not include the user application here, but I have included user application here. So, main.cpp actually instantiate Web2D. This actually inherits place. So, place.cpp. And if you look at the place.cpp, that must be place. I don't see the place. base.h, this includes message, out message, messages and out messages, and then core method. This should be I really wanted to include a virtual void, the core method, but for some reason the compiler goes so that the core method is actually added in the user later. But anyway, so this needs, the place actually needs mObject, the base class. And mObject, mObject includes the core method. This includes the core method. And there is no actual implementation because actual implementation should be done in a 2D. And mObject actually includes instantiate and destroy. So when Web2D is loaded from the disk, then the base class mObject is actually base objects instantiate is called and object is created. So that you don't have to, the math library does not care about the 2D, just care about the mObject and then call instantiate so that object is created. That's a technique to instantiate object from the binary code that has been dynamically loaded from the disk.
You don't
I've never actually seen
interesting.
that occur before. You grab code by name from the disk and instantiate it.
It's because it has to be done on each machine, right?
Mm-hmm.
Has to grab stuff.
Yeah, I mean, it
So
seems
this
like it'd
must
be
be-
useful, but it still seems a little bit like math.
The pathway is.
This is, this magic is actually revealed in CSF 533 next week.
Oh, great.
And, we
Just in
actually talked
time.
about, right? Do you
A little bit, yes, we did.
remember in the last year, 543, about the dynamic linking of the C++ technique? I'm just using what I have introduced.
Taught us, and we should know.
So just for reference, I'll just show the corresponding slides so you can see on the video. Okay, so in C example, we don't have to worry about the object. We only dynamically load the executable program, and then identify the given function name, and then jump to this function. So here, this program actually dynamically loads a given executable. In this example, we have two the executable. One is a lib1, the other one is a lib2. This is just the compiled code that is not included in the program. So the main program does not know about it, that does not include those modules into the memory. And so at the first time, the main program say, okay, library, I need to type library name. So I type lib2. Then the main program calls dlopen lib2, and dlopen finds out lib2, and then load it into the memory. So linked together with the main program. And this module includes function 1 and function 2. So again, I will ask which function the user would like to invoke. So user will give the function name, and with this function name, the main program called operating system function DLC, dynamic linking symbol resolution. Then finding out the corresponding if I type func1, then finding out the address to or pointer to function 1. So DLCM returns the pointer to the function 1. So the rest of it is just call jump to func1, so that now the main program can actually invoke function 1. So this is how the dynamic linking is performed in C, because we don't have concepts in object. Now, if we add C++, how would you like to do that? So, first of all, we dynamically load in the binary code. However, now we need to instantiate it. So this is kind of the one step more than C. So first of all, what should I do? Here, in this example, we would like to create two libraries. One is a lib1 again, the other one is a lib2. But I just say instantiate in order to distinguish them from the C library. I just name this file as a class lib1, and this should be class lib2. And so class lib1 and class lib2 actually have the same class name, but inherits from the base class. And different functions will be fine. But put my data, those functions actually are different. Now what should we do? In order to dynamically link the C++ the class, each class must have the same base class. And in this example, mObject is a base class. And base class should have at least those two methods: instantiate function and destroy function. Please note that those two functions are out of scope. Right? This is the key, because if those two functions are out of class, they are identified as C functions. So that's the key. So here, again, I type, the class lib1, then by coding dlopen, we load the executable module into the memory. Thereafter, now we have to instantiate. First of all, we have to resolve the symbol by giving instantiate. And instantiate is resolved because this is simple C program, simple C function. Resolve it, and then also for later use, we also resolve destroy, because in the future we may want to delete this object. So resolve the function, to destroy the object. So we first of all resolve those two functions. Thereafter, we will call instantiate. Then we can actually instantiate one of them. Instantiate it, and then we can actually call the corresponding function, put my data or get my data. Instead of calling this, because this is virtual function, the actual control goes to the derived functions, function which is spectacular. So this is the technique. So technique is create a base class, and in addition to the base class, we should get prepared for instantiate and destroy function. So then put them together into the memory and resolve those two functions, and we will call this function instead of instantiating the direct way. Call those functions, find out these functions, and thereafter we will call that function to instantiate corresponding the object.
And again, at the big picture, in simple language, is it wrong to say that because each different machine has to bring in this code and dynamically link to it, they need a mechanism to do that, and for C++, there's not built-in things to do it. So you need to use this base class example to bring it in.
Yes.
So as a user of the math C++, for me to write my Wave 2D application, what programs do I need to write? Do I need to write place.cpp?
So here, let's look at the Wave 2D. Wave 2D, you need to just
Follow the
inherit place. So Web 2D just inherit place. Inherit the place actually inherits the M object that includes instantiate destroy, so you don't have to worry about it. So math user, all you have to do is
replace the call method.
implement call method, because this is still virtual. So implement the call method, and then just prepare the corresponding functions. That's all. So that's
And this will be similar then for agent and agent.
yes, agent the same. So here M object is also inherited to agent .cpp, and application here is Nomad. Nomad actually I only include in it because I haven't implemented Core, I haven't implemented the manager, just in it. That's all. So this is something from agent. So this is application, and this is Nomad. So here, agent inherits an object. At this time, I actually implemented map. That's all. I really didn't implement anything at all. Migrate, spawn, and so on. So you need to implement this. All right. What else? So there is some garbage or this program I should clean up. I don't think I need hello.cpp. yeah, I think I should remove it. I will remove it later. This time if I remove, then I made a mistake and remove something important. So, and then what else? Next. Base class. Oh, this is the what I showed. So first of all, I just brought those C++ codes from CSS 533 or 543, tested, and then from that I modified the base class.cpp to image object.cpp. Yes, so this is exactly driver CPP. This is actually this one, driver CPP. Just teaching materials main function.
And that's been replaced now by,
So this portion is included within that.
okay.
Actually, the last case of because all the computing node has to dynamically load agents and process. Okay. What else? Exchange hello. This is the just test program. I explained math, yes. So the rest of it is message and mthread, right?
And derived place, DLL
Oh, yes.
class.
Yeah, derived.
Looks like it's just a sample for the user.
Yeah, this is
Sample
a yes. This is the sample for user.
So that can come out here.
And then yes, this is the extruded from the mass to dynamically actually perform dynamic linking. So that includes DL open, DL send, and then identify, instantiate, and destroy function. So each DLL class actually includes different agents, place, and so on. So every time new agents or places are loaded, then one DLL class object is instantiated and then maintain instantiate, and destroy. And they are used here. DL, the DLL class is or basics. That's it.
So I don't know, in GPU, what you have to do is, shall we combine this dynamic linking and GPU? You know, maybe we have to ask users to compile everything at the beginning. In that case, we can actually remove this DLL operation.
So, I'm starting to wonder if it would be easier to start with, I guess, the GPU places that have already been done, and start modifying the existing C++ code, simply take advantage of the parallelization.
So yes.
It seems like just trying to start over and recreate this, it's going to be way more work than we'll get benefit.
But the easy way to the GPU, first of all, you don't have to worry about
Yes.
this portion.
All the slaves are going to be running on GPU.
On the GPU.
The challenge I'm seeing with the GPU in terms of agents is you can get a block of, I believe, up to 256 threads that run contiguously. They can all talk to each other. When you go beyond that, they lose that ability to chat. So let's say you have really large places and you're trying to move agents around. Well, for those 256, it's pretty easy. You can move them from one to another, but if they have to move beyond that range, that's where I'm kind of stuck right now.
I see.
And I still have more to go in my class, but hopefully they'll get to that.
Okay. We have to copy, maybe.
Yeah, they haven't even touched on the. There is, overall shared memory on the GPU, and so undoubtedly you've got your main memory down here, and whatever your little blocks and threads running up here, and probably you'll have to put it down here, and then you've got your other threads, and then we'll bring it back in there.
Okay. All right. So it's 2:55. Should we just look at the call?
And then we're done.
The way down. Yeah. Okay. So first of all, let's look at the user program. User program, after instantiate agent displaces, then you can actually invoke call or an exchange all. So let's look at the call. Call is implemented within placeit.cpp and here. Call actually has 3 overloading functions. Just includes function ID or the receives the arguments or receive an array of arguments. If it's array, then each element should be labeled to the different place. If there is only one argument, then this argument is distributed all places. Right. Then after being invoked, all function calls goes to CA setup. And here the CA setup. What CA setup is the calculate agent the argument size and the return object size. The reason is, the third one is requesting the return values from each place. So we will just calculate the size, and then this portion send a message to each slave that includes message call all void or message call all
return object. So
It's up above it.
yeah, here. Okay, so then this is the argument body. We calculate the body and the body size. Thereafter, after creating message M, and then just send it. So since M node maintains the SSH connection to each slave, so we will just call M node I, that corresponds to the slave I, and call send message M. So that this message will be sent. But within the within send message, we call message dot serialize. So entire message is serialized into the byte code, actually the byte string, and it's sent in one message. And then, of course, in C++, we have to make sure that message must be deleted. Otherwise, memory leak occurs. Okay, once the message is sent, now the master should be also working on call, because master is also the part of the computation. So set up all information to say function ID, argument size, and return size to mass base current place, current function, and so on. Those are the information that can actually share M threads. I forgot to mention about M threads. M threads is the thread that works on the portion of places. So these variables are the shared memory, and they are visible to all threads. Then we will resume threads. So the threads actually always wait at the top. Const C thread, const E thread, const wait. So by calling resume threads, then threads will be woken up and then check these variables and work on the corresponding function.
I'll just stop that.
Do you have a question?
No, it's okay.
She knows that this room is empty and it can be a study room. So after resuming the threads, main thread itself also wants to be a part of computation. So just call places base call. So within the call the places base we will go into the call. And after the call is done, then all threads are synchronized together, barrier synchronization, and that's all. So let's look at the places base call. So the places base the call. This is executed by each thread. So each thread will execute call, and for this purpose, first of all, compute each thread's the assigned range of the place.
places, because places are just the striped into the very small chunk, and each chunk is assigned to a different thread. And then we will find out corresponding the places from the DLL map. And we'll find out is the corresponding class. Then we will go to each element. So range 0 to range 1. Range 0 is a lower boundary, and range 1 is the upper boundary of this chunk.
And the reason that we have to look at it each time we come into call all is because of the dynamic load balance.
Right, yes.
So between each barrier synchronization, we can resize the number of places per thread.
At this time, C++, I have not implemented it.
But that's why you're thinking ahead
yes,
too, right?
yes, right. So that's why. And then, for each place, we will just call the call method. That's all. Okay. So let's look at the M thread. So M thread, when it is instantiated, is actually, first of all, M thread object is, so this is the first function executed by the main thread, not all thread. Main thread actually initializes all condition variable, mutex variable, and so on. Then all child thread and main thread, all child threads start from the right. And then go into the while loop. Okay. While loop and wait on barrier ready lock. So status ready means nothing to do. So go into here and just wait. And when the main thread say resume thread, then resume thread actually wakes up the child, and the child actually can go forward. And it can go forward and then perform each task. So check this status. If the status is ready, then of course the if the state is ready, this is going to be a map because if state is ready, then it should be wait. So just the call exit, and the entire system is just crashed. If the state is terminated, then running becomes false, and just go back, and running becomes false. So get out of the while loop, and this thread will be terminated. If the status is call all, then by calling get current place, and so get current place, that current the functionality, those are the shared variable which the main thread actually stored, and so the child thread actually reads all those the shared variables, and then call the places call places call. So each thread is now going to places call, and as we looked at previously, each thread compute the local range and perform each invocation of each the place call method function. Status exchange all, then the thread will actually perform exchange all. So, and then after performing each task, they will reach the barrier so that all the sweep thread and main thread will be synchronized here, and the escape thread will again get on to sweep.
So the resume thread, this is called by main thread, and so the all CA thread will be woken up. So that's why there is const broadcast. This is the same as Java's notify all. Barrier thread, this is the just the barrier synchronization. The very last thread will be woken up. And the logic is the same as CSS 533's laboratory one. We did it.
Oh, yeah.
Yeah. So barrier synchronization. So this is a C++ function. So at the very end, that's the review again. mprocess.cpp. mprocess.cpp is also the thing to the while loop and waiting the received message. And once the action or command came from the master, then mprocess examine this action, examine the action, and then go to the corresponding the case statement. And if we each slave receives call all, then from the message, the end process initialize shared variables. Those are the shared variables that should be given to each M thread. And then resume M threads. And then both main thread and the slave thread goes into the call. They perform the invocation of call method for each place. And then various synchronization will hold on and send back acknowledgement from each end process to the master process. That's all. So extend all the same. The command will be coming back end process and the main process and resume the thread and go into extend all function, various synchronization, and end process and acknowledgement. I think we're done.
Have you done any performance of just the initialization of Java versus C++? That's the one area I think is going to make a big difference.
Actually, I haven't performed the conducted performance evaluation, but from my visual observation, this is really fast.
Cool.
It's just like probably less than 1 second. Everything will be done. So very, very quick and very exciting. And Java at the very beginning, all M processes just handshaking and we have to wait and so on, and then run gradually. And this one will be really fast. Oh, didn't I record it? No, I recorded it.
It
Yes.
was.
Oh,
It was
yes. Okay.
Did it stop at 1 hour or something? It's about when we started 10 after. But if someone has a camera, at least take this one picture as a backup.
It's 1 hour, right?
Yeah.
I think the icon down in the system tray shows.
Oh, yeah.
Yeah. You still have to tell it to stop.
At the very bottom, the audio is going up and down.